Alright, so here we have an astronaut that's in space while he's working on his craft. All of a sudden, while he's working, he accidentally bumps his wrench and continues to work. Once he sees the wrench, he sees it at the position vector -2, 4, 3 meters. This is after no time. This is the first time he sees it. This is the first point that he realizes it's gone. He says, "Oh man, frick, I need my wrench. It's gone." So he keeps watching it. And after watching it float away for about 4.5 seconds, it is at the position vector -11, 8, 4 meters. So here in this problem, we want to find what is the average velocity. We want to figure out what is the magnitude of the average velocity. And we want to see what the unit vector is and the direction of the velocity. So here we have a fun little picture, thanks to my somewhat viewable drawing skills. So here we see the astronaut initially realizing at time interval 0 seconds that his wrench is floating off, and it's at the position vector -2, 4, 3. And then after 4.5 seconds in the second time interval, we see the second position to be -11, 8, 4. Alright, so let's get to it. So for the first part, while we're trying to find the average velocity, we need to recognize the fact that we need to know both of these things. We need to know the change in position over the change in time, because velocity is meters per second. It's distance traveled over a period of time. So here we have our change in velocity represented here by our final position minus our initial position. We're going to come out with -9, 4, 1 meters for our position vector for our change in position. In our time interval, we know that his initial position vector is seen at time interval 0, and we know that at the second position vector, the time interval has been 4.5 seconds. So we're going to subtract 0 seconds from 4.5 seconds to give us a time interval change of 4.5 seconds. So here we have our change in position shown above, and we're going to divide each change in position by our time to give us meters per second. So we come out with something around -2, and then positive 0.89, and then positive 0.22. For our second part, we want to figure out what is the magnitude of the average velocity. So we're going to use the Pythagorean theorem relationship, and we're going to find the magnitude by squaring each of our x, y, and z parts of our position, and we're going to take the square root of it. So we have -2 squared plus 0.89 squared plus 0.22 squared. These are our values from above, from our average velocity. We're going to take the square root of that whole value, and we're going to come up with the magnitude of the average velocity to be 2.2 meters per second. This tells us how fast our wrench is moving away from the astronaut. It's moving away from the astronaut at a velocity of 2.2 meters per second, a magnitude average velocity. We don't know the direction here because it's just our magnitude. It's just our overall speed going away from the astronaut. Finally, let's look at C. What is the unit vector in the direction of the velocity? So here we need to recognize that our unit vector of our average velocity is going to be our average velocity vector divided by the magnitude of our average velocity vector. So we have both of those values from our previous parts, here and here. So we're going to go ahead and plug those in. So we have -2 meters per second divided by our magnitude, 2.2, and likewise, carrying on. So that our unit vector is going to be -0.909, 0.405, and point 1. Thank you.